Hi everybody, good morning. Today is September 20th. Oh, okay. So this is September 20th. I put 29. So today we will continue to finish session 3.4 and then Friday we will talk about 4.1. So please make sure you have 4.1 worksheets on Friday. Okay, everybody? And then next Monday, we have homework 3 and quiz 2. And then next Friday, we have our first exam. Oh, okay. So do you want to take it like earlier in my office hours? Probably like Thursday or Wednesday? Huh? Wednesday? Can you take it on Wednesday? You have to make a plan. You have to find a time to take the exam. So we only have the makeup exam before the class exam date. You cannot do it after. Okay, so it's find a time before Friday. So yes, email me what are your available hours, and then yeah, we need to find a time to make up the exam. Okay, before you leave. Yes. Okay. And right, so let's first talk about our quiz. So you did the first quiz, and this is the solution. The first problem, we want to evaluate the limits, right? And when you plug in 3, you realize you get 0 over 0. So that means we have a bad guy, right? So if you see difference of square roots, if you see a square root, multiply by its conjugate. So you see your upstairs, the conjugate is the two terms remain the same, but the sign, you change it from minus to plus. Do you remember, everybody? Conjugate. And why we multiply by the conjugate? Because we use the formula a minus b times a plus b equals a squared minus b squared. The square can cancel the square root. So that's why you have, see, the square root cancel. Then x squared plus 7x minus 21 minus x squared. Don't forget to square this x. Because now you cancel the x squared. The 7x minus 21 has a common factor 7. You factor out the 7, and then we have x minus 3 left. And you know 3 minus x and x minus 3, you can swap one of them, but you have a minus sign in front of it. Right, everybody? And then this is the bad guy. We cancel the bad guy, and then we plug in the 3 again. We get minus 7 over 6. So that is the first problem. If you have mistakes on your quiz, you can make corrections on next to your solution on the quiz. So you know, okay, what mistake you make and what is the correct way to solve this problem. And in the exam, you have some problem like this. So make sure you know how to do it. Then hopefully you can solve the problem in the exam. Number 2, you want to find the vertical asymptotes. So make sure you show one-sided limit to verify the existence of vertical asymptotes, and use two-sided limits to show the non-existence of the vertical asymptotes. Okay, so the first thing you do is factor. And do you see the bad guy is x minus 3? Yes? So actually from this step, we already know the vertical asymptote is going to happen when the 2x plus 1 is 0. And x minus 3 is 0 won't give us a vertical asymptote. So we know the conclusion at the first step. But you have to show why. Okay? You have to show why. So that's why if you just write down the first steps, that's only 1 point. The y is about 4 points. So you talk about the domain, the denominator cannot be 0, so x cannot be minus 1/2 and x cannot be 3. And the minus 1/2, you, Okay, let's see. The minus 1/2, we check the right side of limits. And remember here, you plug in the what? The factor form. Don't ever plug in the original one. Okay, everybody? So plug in the factor form. You get the numerator is positive, the denominator goes to 0 plus. That's why we get positive infinity. And then next one, we check the right side limit of 3, and you cancel the bad guy, you plug in, you get 6/7, and that's not enough, because to show there is a vertical asymptote, you actually need to prove the two-sided limits is not infinity or minus infinity. So I have mistake here. Let me fix it. Okay. Let's see, where's the quiz? Quiz 1 solution. Here. Okay. So, do you remember in class what I said? If you get a number, then you just go back and erase the plus. Then you get the two-sided limits, both equals to 6/7. Do you remember that, everybody? So now, remind you again. See, sometimes I make mistakes too. So when you do your exam, please check your work, okay? After you finish it, let's see. Oh, it's because I already opened it here. Okay, so try again. Hopefully it will be updated. So once you get a number, go back and erase the plus sign. Okay, so we make sure we check the two-sided limit. Okay, next, let's look at mistakes. So everybody, I have your permission to print screen the mistakes and go over with everybody, right? And I want to say, don't be shy, don't be afraid of making mistakes. You see, I make mistakes too. It's okay to make mistakes. We're all family members, right? We help each other. Mistake is our teacher. Just learn from it. Okay. So here, right, this step is right. Then you know you have two numbers you need to check. So here, that's one number, but then where is the other number? That's why you lose 2 points. Is that okay, everybody? So you know, even though you know we don't have a vertical asymptote here, but why? So you have to verify the two-sided limit equals the number. It's not infinity, it's not minus infinity. Then this is why we don't have a vertical asymptote there. Okay? Yeah, so make sure you don't miss some steps. Okay. Here, see? This number is positive, and 0 plus is positive, so you get infinity. You don't get minus infinity. So that's a mistake. Yeah, so be careful. I only subtract 0.3, yes, because of the minus sign.
Professor,
Yes?
but I noticed on some of the open math homework, when it was plus 0, it usually would make it negative infinity.
Is it because it's minus 7/0 plus? If you have one minus
that was
sign?
the case, and that would be negative infinity?
Yeah, you count how many negative signs. If you have, okay, let's say we have this. How many negative signs? 1, 2, 3. So the answer is negative. So odd number of negative signs multiplied together is negative. And even number of negative signs will give us positive. Yes. Right. Okay. So it's good to know that confusion now, so you won't make this mistake again in the exam. Okay. So quiz is just help us to do well on the exam. Okay. Here. Don't factor the things inside the square root. Actually, if you multiply out x plus 3 and x minus 7, you will get x squared minus 4x minus 21. You don't get the positive 7x. So this is not the correct factorization. Is that okay, everybody? Is that okay? So what we should do is we multiply by the conjugate. Yeah, so here, conjugate is good. It's just this one. Don't factor it. Just leave it here. So leave this guy here. Then you realize you can cancel the x squared. Right. So, okay. So that's why I hope if you make a mistake, write down the a mistake sheet. Okay, so let me see. Do I have a mistake sheet up here? Yes. Do you see this mistake sheet? So this is what I suggest you to do. If you have a mistake on your homework or quiz, write down the mistake here, and then write down the correction here. And what do you learn? Like for example, that problem, you can say when you see square roots, multiply by its conjugate. Don't factor the things inside the square roots. So write it down. Imagine before the final exams, what can you do? Well, you have a lot of notes, right? It's hard to review all the notes in one day. Do you agree? And sometimes you have other exams as well, like happening in the same day. So you have limited time. So if you make this mistake sheet, you can review the mistake sheets. Because usually if you make the mistake like this is the natural way of thinking. So it's very likely you make the mistake again. But if you have this mistake sheet, it can help you to remind yourself, don't make this mistake again.
Does the mistake sheet count for points too, like extra points?
No. It's just a way to study math. I think it works for all the science subjects. Like if you make a mistake on your physics or chemistry, I think it's just a habit. This is what I did before when I studied, right? Okay. All right. So, okay. And then here, let's see. Oh, when you evaluate the limit, plug in the factor form. Don't plug in the original form. Because if you plug in the original form, you only get 0. You don't know it's 0 plus or 0 minus. Okay, everybody? So you don't know it's infinity or minus infinity. We don't know because it won't tell you. So you must plug in the factor form. Do you see if you don't plug in the factor form, you get 0 over 0. When you see 0 over 0, what does that mean? Bad guy. Okay? The problem I asked you in the exam, you never have no conclusion. You can always use some methods to cancel the bad guy and get a number. Okay, that number is either really a number or it's infinity or minus infinity or the limit does not exist. But you never see something 0 over 0 that you cannot determine what the answer is. Okay, everybody? So, right. And here, multiply by the conjugate, those two terms remain the same. So don't pick 3, it's x, okay? It's x. And you change the sign from minus to plus. And it becomes x squared, not just x squared. And the denominator, don't forget, you have the plus x. Okay, everybody? So that's why this is the mistake. Okay. Limit. Oh, right. If you cancel this, then you can factor out the 7, and you can see the bad guy and cancel it. Right. So here we don't need quadratic formula. Okay, we just plug in the 3 inside the formula. Is that okay, everybody? So make sure you know how to solve these problems. It's okay to make mistakes. Quiz and practice exam just help us to be ready for the exam. Because if you just look at me like solve the problems in lecture, you kind of understand it, right? But if it's your turn to do the problems, then maybe you forgot some steps and maybe you make some mistakes. So it's very important to do your work and then figure out the mistake and remember it. What is the correct way to solve the problems? Okay, everybody? Our class time is very limited. I wish if I have more time, I can do 1 example and then you guys do 3 examples. But unfortunately, we only have 15 minutes, right? So I hope you do more exercise at home, okay? Or come to my office hours. And if you come to my office, we don't have a time limit. We can go over the problem like slower, and I can give you more practice to do. Okay? All right. So and then here. Oh, let's see. What's wrong? Oh yes, Mr. 3. Okay, so Mr. 3. Yes.
And if you can't sleep well, why do you need to do it?
because you want to show why we don't have a vertical asymptote there. Why?
You already canceled it.
You cancel it, but the domain you still need to include is not equal to 3 in the domain. So even though we know that there's no vertical asymptote, how do you prove it? How do you prove it for sure we don't have a vertical asymptote there? Yeah, how do you prove it? Using the limits. You check both sides. You go to a fixed number. You're not going to infinity or minus infinity. Then for sure we don't have a vertical asymptote there. This is how we show it. Why? This is why. Okay? So make sure you do that. Okay. And then here. Oh, yeah. So here, just go back and erase the plus. See? I make this mistake too. So go back and erase the plus. Then you have the two-sided limits. Okay, everybody? Yes. Okay. Let's see. Here. Oh, okay. The factoring. This is x minus 3. So it becomes x not equal to 3. That's why it's the round number here. And so here, don't put like this number. If you just put this number, you just get a 0. Okay? Remember the corresponding factor. You replace the corresponding factor 2x plus 1 by 0 plus. So for other factors, you plug in the numbers. But for the corresponding factor, don't plug in the number. If you plug in the number, it only gives you 0. Okay? You replace by 0 plus. If you go to that number from the right, you replace by 0 minus if you go to that number from the left. Is that okay, everybody? All right. So, okay, that's all the mistake. Any questions about quiz 1? Okay. So, yes, I hope you can do more exercise. And at the bottom, do you see this practice exam 1? So today, after today's class, we finished 3.4, and then please do this practice exams. And you first use pencil to finish it, and then look at the solution. Use red pen to grade your work, and please check carefully, not just the final answer. That you show every step. Okay, everybody? So even though you know we don't have a vertical asymptote there, but do you miss the step to show the limits equal to a number there? So check carefully. Make sure you have every step. Okay? And assign some points. So I want you to be a harsh grader. See how many points you get on each problem. And then add them up and get your total scores. Okay? If your total score is low, look at which problem you lose so many points, and then find some other example to practice. Okay, everybody? So some of my students, they said they do the practice exam 3 times. The first time they do it one week ahead, and then the second time they do it like 2 days before the exam, and then the last time they did it the night before the exam to make sure they fully memorize how to solve all kinds of these problems. Okay, so you can use the practice exam as like a study guide. I will ask you similar type of problems in the exam, but I don't guarantee they have the same difficulties. So the problems on your actual exams might be harder.
So for the exam, would it be 10 questions?
Will be less than that.
And
Okay.
For 50 minutes?
Huh?
It's 50 minutes.
It's 15 minutes. But I will be here like at 9:50. So do you have a class before this? Okay. So maybe that day after your class, you want to pass her here, and I have another class here at 11. So if you need more time, you just stay longer and you finish your exam, and then when you finish, just give it to me here. But I will be teaching in this room. Okay? So if you need a little bit more time, feel free to stay a little bit longer. And when you finish, just give me the exam and then you leave. Okay, everybody? Yes. Do you have a class right after us? No? Okay. Good. How many of you have class right after us? Okay. Do you have class before us?
No.
Okay. Then maybe you can come earlier.
Well, I mean, I'll still be here next Friday.
Oh, you're here this Friday? Next Friday? You'll be here? Okay. Yeah. So yeah, then you don't need to make up the exam. You can come here early. All right. So let's see. Okay. Right. Okay. So let's see. Okay. Last time we talked about the tangent line. Remember those two formula? It depends on the second point. How do you call it? Okay. The first point is always a. The second point, if you call it x, then the formula will be limit f of x minus f of a over x minus a. Do you remember the slope of the secant line? And then if your second point is called a plus h, then the formula will be f of a plus h minus f of a over the denominator. The difference between them is now h. Okay? And then we agree to stick with the second formula because you don't want to get confused. If there's so many methods in your mind, sometimes it's very easy to get confused. So let's stick with the second method. Okay. And then we did example 1 and we did example 2. Right, everybody? And then now let's talk about in general the definitions of derivatives. Okay? Is the function f such that so we have f prime is the limit. So derivative is actually the slope of the tangent line. And do you remember before the slope of the tangent line at a single point A? We had the formula f of a plus h minus f of a over h. Now you let the a be a variable. Let the a moves. Okay? Then if the x goes from the domain, and then you have this become a function of x. Okay, you kind of simply replace a by x, and you get a function of x. So this is the derivative. It's the slope of the tangent line. And if you want to draw the picture, so this is the picture. Like here, this is the tangent line. And you let x move. Here, this is tangent line. 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 So you let the x moves, you get a lot of different tangent lines. So your slope will be different. It's a function of x. Is that okay, everybody? All right. So let's see here. If the derivative, if this limit exists, we say f is differentiable at x. Okay? If f is differentiable at every point on an open interval, then we say f is differentiable on the interval. So here, this is the picture. Now we have, this is some other notation. They mean the same thing. So this is like x, and this is like x plus change of x. Change of x is the same as h. Is that okay, everybody? But some textbooks notation, they like to use change of x. Okay? It's like here, change of y, here, change of x. So this is the same thing. Okay? Therefore, in notation, change of x goes to 0. We use differential dx to denote. So this is dy dx. Okay, everybody? And all of these means the same thing. So for derivative, you can use f prime of x. You can use dy dx. And you can use df dx. Or you can use d dx. It's like an operator, it adds on the function f. Okay? And you can use this capital D, small x, f of x. And we usually use this notation in Calculus 3. I know you guys don't need to take Calculus 3, but Calculus 3 we talk about multivariable calculus. So instead of just x, you might have y, you might have z. That's why they use this notation. So you can have dy, and you're taking derivative besides y or dz. So we have 3 directions. Okay, so x, y, and z. Okay, in the space. Or we can use y prime of x. So all these notations mean the same thing, the derivative. And how about the derivative at a particular point? Well, you can plug in x as a, so this is the derivative at the point a. Or you can have, this is the derivative, evaluate at x equals to a. Or df dx, evaluate at x equals to a. Or you can put y prime of a. So all these mean the same thing, the derivative at x equals a. Is that okay, everybody? Just notation. All right, example 3. How do we find the derivative of this function? Okay. So here we're using limit definition to find the derivative. So you might learn some derivative rules before, okay? Or we will learn derivative rules later. But for the problems in this section, when they ask you to find the derivative, you have to use this limit definition. Is that clear, everybody? There are other differentiation rules, much easier, but problems in this section, you have to show by the limits definition. Okay, so find the derivatives. So f prime of x. Limit definition. Limit h goes to 0. F of the second point, remember, x plus h minus f of x over h. Can everybody remember this formula? The 2 points. The first point you apply x, and the second point you apply x plus h. Okay, everybody? So make sure you memorize this formula. Okay. Yes. This is the start. And then, what is f of x plus h? Well, that means you see the formula of f. Replace x by x plus h. Be careful. This is not f of x plus h. Okay? So be careful. The common mistake is student put 3x plus 5 minus h. No, not like that. Okay? It's whenever you see x, see, you see x, replace x by x plus h. And then the other terms remain the same. Is that okay, everybody? Minus square root of 3x plus 5 all over h. Okay, everybody? All right. Now, what do we do? Okay. Look at the numerator. This is the same as we distribute. Then we have 3x. Distribute, we have 3h plus 5. Do you agree? Oh, I have my limits. Make sure you have the limits every steps if you still have the h. So in this expression, h is like the variable and x is just like a constant. Is that okay, everybody? The limit h goes to 0. H is changing. The x remains the same. It's like an x number. Okay, if you see difference of square roots, what do you do? Yes, multiply by the conjugate, right? Like your quiz. Your conjugate will be 3x plus 3h plus 5. And then what? Plus square root of 3x plus 5. So you multiply by the same thing in the denominator. Is that okay, everybody? Okay, now the numerator we can use the formula a minus b, a plus b is a squared minus b squared, right? And the a squared, you can cancel the square roots. So a squared will be 3x plus 3x plus 5. Is that okay, everybody? You cancel the square roots. Minus b squared. B squared. Don't forget the parentheses. What's b squared? What's b squared? Yeah, 3x plus 5 all over h. Good. Now let's see. Limit h goes to 0. 3x plus 3h plus 5 minus. This should be the negative. What do you get? Yes. Oh, what can we cancel? Oh, do I miss something? I missed this drawing denominator. Did I? You see? Oh, we still have this drawing denominator. So 3x plus 3x plus 5 and the 3x plus 5. Okay. H, the 3x plus 3h plus 5. Make it longer. And 3x plus 5. Okay, numerator, what can we cancel? Yes. Oh, wonderful, wonderful. Do you see now the numerator is just 3x? Can you see the bad guy now? Yes. See, that's my mistake. Yes, thank you. Right, plus, plus. That's why I told you, before I turn in my exam, I have to check carefully. I remember one of my exams, I checked 5 times, and every time I can find a mistake. 5 times, every time I can find a mistake. So yeah, I would say, my students, if you have time after you finish your exam, check 3 times. Okay, check 3 times. If you have time, check 3 times. Don't turn it in early, because you want to get as many points as you can. If you get exam bad, you see some points, oh, I know how to do it. I just made a small mistake. And then you really want to punish your points, right? Yeah. Yes. So get all the possible points you're able to. Alright, do you see the bad guy? Who's the bad guy? The age. We cancel the bad guy. Then we are safe, right? We are safe now. Okay. Alright. Now it's safe. We can plug in h is 0 again. Do you see when we plug in h is 0? This term is gone, right? Then do you see this guy and this guy, they are the same? Mm-hmm. So you can combine them and you say 3 over 2 copies of this. Okay, everybody? So we have 3 over 2 copies of square root of 3x plus 5. And this is the answer. You see the derivative is a function of x. Okay, everybody? So at a different point, you get a different slope of the tangent line. So this is a function of x. Like the previous definition. So here, the derivative, you get a function of x. And when you plug in x equals to a number, then you get a number. Okay, everybody? So that's the answer of example 3. Any questions? Yes. Yes, find the slope of the tangent line. Yes. I can show you. Let me see. Do I have it here? Okay. So use GeoGebra to verify derivative at slope of the tangent line. So look at this picture. Alright, the green line is the function. And do you see when the point goes around, you have your tangent line and your slope of the tangent line. So this red dot is the slope of the tangent line. Okay, everybody? Do you see it match the yellow curve? The yellow curve is the derivative. So you can see the the derivative is the slope of the tangent line at that point. Okay, everybody? And this is the GeoGebra project. Extra credit. This is an extra credit. So GeoGebra projects. Each project is 0.5% extra credits. So this is the PDF introduction. Okay, so you can go to this link and download GeoGebra Class 6. It's free. I recommend you to download to your computer. Don't use the online one. Because if you use the online one, the location of some buttons are different than my screenshots. Okay, so it's better to download that one. Okay, and then this is the YouTube video I make. How to make the animations project. And then 3. So after you watch the YouTube videos, and then here you have a step-by-step screenshot. Okay, you can make up a function. Please be creative. Don't pick the same thing as mine. Okay, be creative. Make a different function, and then you can set some that the points can go around, and then you can draw the tangent line, and then you can write down the tangent line slope, and so you can let it runs. Okay, let it runs. You get the trace out of it, and then you can also find the derivatives. So at the end, once you finish, you save your projects. So when you save, they ask you to log in. Do you have Google account or Office account? Yeah, in the other tab, Office account, right? You can log in and then you click save and share. Okay, share. And then you have a title and put your name here, and then you save. They will give you a link. Okay, they will give you a link. Send me this link. Then you get 0.5% extra credits. Okay, everybody? Yes. All right, good. So the extra credits, how many extra credits you can get? So this is GeoGebra projects. There are 2 projects, so you can get at most 1%. Right? 2 projects, each is 0.5. And then you also have the attendance bonus. If you miss no more than 2 classes, you also get 1% bonus. And then you have the note-taking bonus. If you have been taking all your notes and show me at the end of the last week of the semester, you also get 1%. So together is 3%. 3% is quite a lot. It can help you to move up in grade, right, everybody? Oh yes. And also at the end, we have a student evaluations. If all of you fill out the student evaluation, everybody will get extra credit as well. So we will talk about that later. Yes. Okay, very good. So let's continue. Show this function is not differentiable at 0. Do you remember what's the graph of absolute value of x? Yeah, like this. Right? Like this. And here, bless you. Do you see here the slope is 1? Yeah, 45 degrees slope is 1. Do you see here the slope is minus 1? Yeah, so that's why at 0, the derivative is the slope of the tangent line. Here, if you go from the left side, your slope is minus 1. Here, you go from the right side, your slope is 1 because they're not the same, so it's not differentiable. But how do you do it? So this is how you prove it. Okay, so the derivative at 0 by definition, is f of 0 plus h minus f of 0 over h. Is that okay, everybody? This is the definition. And what is this? F of 0 plus h is the same as f of h. Do you agree? F of h is absolute value of h, because f of x is absolute value of x. So when you plug in x is h, we get absolute value of h. What is f of 0? What's absolute value of 0? Absolute value of 0. Yeah, is 0. And over h. Oh, here? So f of x is absolute value of h, right? So f of 0 plus h is f of h. So f of h means whenever you see x in the expression, you erase the x. See, you write the expression, you erase the x, and you replace by h. This is why you get absolute value of h. Is that okay, everybody? You erase the x and then replace by h. Okay. And when you subtract 0, it's just absolute value of h over h. Okay. Now here comes, if you let h go to 0 plus, how do you break absolute value? Okay. Absolute value, how you break it? If h is greater or equal to 0, then it's just h. Do you all know absolute value is always greater or equal to 0? But if h is negative, because h is negative, the minus h will be positive. Is that okay, everybody? This is how we break it. Therefore, the right side of limit, because h is greater or equal to 0, absolute value of h is h. Therefore, h cancel, we get 1. Is that okay, everybody? We get 1. And then the other side, because now h is less than 0. What's absolute value of h? If h is negative, yeah, negative h. What happened? You cancel the h and you get negative 1. Do you see they are different? If your left side limit and right side limit do not match, then you can conclude this limit does not exist. So f is not differentiable. So we can get this conclusion. Right? In order to have a limit exist, you must have left side limit and right side limit agree. If they don't agree, then the limit does not exist. Then your function is not differentiable. Okay, everybody? So we have seen example 3, where you can find the derivative using the limit definition. And then example 4, you show the limit does not exist. So it's not differentiable. Okay, everybody? Alright. Yes. Oh, sorry. Okay. Make it smaller. Okay, example 5. Use the graph of a function f to sketch the graph of its derivative. Okay, so knowing the graph of f, how do we find the derivative? Everybody keep in mind, for lines, we have this, what do you say about the slope? Positive, next one, negative, this one. Horizontal line, slope is 0. Last one. Undefined, yes. So derivative is the slope of the tangent line, right, everybody? So here are the steps. Write down the steps. First one, find the point where the slope is 0. Okay, find the point where the slope is 0. And then you draw the x-intercepts. Is that okay, everybody? Because you want to draw the graph of the f prime, the derivative, is the slope of the tangent line. Do you see here, like at A? See? Use your hands. Everybody raise your hands. And then you kind of travel. Do you see here the tangent line is, the slope is negative? And then you go. Oh, here, the slope is 0, right? And then you go. Oh, your slope is positive. And then you go. Oh, it's like playing a roller coaster, right? The slope is 0. Slope is negative. And then here, slope is 0. And then here, increasing. Oh, slope is positive. You find where the point, the slope is 0. And then because you want to draw the graph of the derivative, then you know you must have an x-intercept here because the slope is 0. Okay, everybody? So find where the slope is 0. Then you can draw the corresponding x-intercept. So x-intercept. And then here at P, do you see the slope is 3.2? 3/2, which is 1.5, right? Everybody? That's 1, that's 2, 1.5 is like here. Do you agree, everybody? Here is 1.5. Okay, so plug those points because you know the slope at those points. Right, everybody? Okay, that is the first step. Second step depends on is it positive or negative slope, then you draw differently. So if you get your slope is positive, then how do you connect them? You know your function lies above the x-axis. Okay, everybody? So this is above the x-axis because your slope is positive. And then if your slope is negative, what do you say? Below the x-axis. Okay, let's see. On the left, what do you say? The slope is positive or negative? Positive? Negative, right? Everybody? If it's negative, then it's above or below the x-axis? Below, right? Yes. Oh, it said that at P, the slope is approximately equal to 3/2. You know, 3/2 is 1.5.
So the P is 1.5.
The slope at P is 1.5. The P is 5, 1. The point P is 5, 1. But the slope at that point is 1.5. So that's why you plug that point. You have your x coordinate the same 5. So your slope is 1.5. The y coordinate is 1.5. Is that okay, everybody? Okay, so that piece we know slope is negative. That's why we know it's below the x-axis. How about here? The slope is what? Plane. Positive. Then it's above or below? So positive above, right? Above x-axis. So you connect those 2 points above. Woo! Here. What's your slope? Down. So yeah, down, right? Okay. Yes. So connect those 2 points and it's down. And then Dylan, what do you say? Positive. So woo. Actually we just connect those 2 points, right? And it's above the x-axis. So we got the, sorry, I don't mean to erase. I don't want to erase. Okay. All right, so let's see, like this and this. They just connect them smoothly. This is the graph of the divergence. Is that clear, everybody? Yes. Let's continue on Friday. We're a little bit behind schedule, but it's okay. But I hope you can like start working on your homework and also working on your practice exams. Yes. Oh, you didn't get. Oh, did my alarm ring sometime? And I just. Oh, can I borrow it? Everybody is here, right? Okay. Thank you. Yes. Oh, let me